conversation.
Good evening, everyone. Well, welcome to the August edition of the Microsoft 365 Meetup for Government. Very glad that you were able to join us this evening. Before we get started with tonight's content, a few disclaimers and administrative items. If you're new to this meetup and this group, we're a online distributed community of professionals, interested individuals, and in some cases academics who are interested in Microsoft 365 and the cloud and its applications within the government space. Was certainly a broad topic, and we cover a lot of ground, but really the goal here is around networking, professional growth, and learning, as well as continuing to grow and learn and network on the various solutions that are within this space. Just a note, we certainly ask everyone to kind of practice basic courtesy and professionalism. Please be considerate to others. Do not share information in this forum that's not you're not authorized to share or may be proprietary or confidential. Many of us are employees of whether it be Microsoft, other companies, or potentially government entities, but everyone is here in their capacity as personal individuals. So this forum is not intended to reflect the positions of any of those organizations. I do want to, as always, extend a warm thank you to Andy Oak and Andrew Kagan, my co-organizers. We certainly could not have this community without them and their support. And certainly if there are folks who are interested in contributing as well or getting more involved, we definitely welcome you. This is definitely intended to be a community for that community, of that community, and by that community. If you don't know me, I'm Nick Giard. I'm a product manager with Microsoft, working in the space of Office 365. And if you're new to Teams, certainly welcome to the platform. Some of the icons on this particular screenshot may be a little outdated as some of the upgrades happen, so we may need to refresh that. But definitely make sure you know where the raise hand button is, how to access the meeting chat up in the top toolbar. Certainly put any questions or comments or discussion within the chat, and we'll be happy to help you. Or if you have something you'd like to raise your hand, and we can get you unmuted and you can ask your question live. So without further ado, would like to introduce tonight's topic and speaker. We have our very own Andrew Kagan, who, in addition to being a founder and coordinator of this meetup, actually happens to know a thing or two about technology and his day job as a chief technology officer. So very grateful to Andrew for him to share some insights and knowledge about this very rapidly evolving and complex topic. So Andrew, over to you.
All right. Well, thank you so much. Let me just get the presentation started. And once I do, please let me know if you can see it. Hopefully that is the case.
Looks great, Andrew. You're all set, man.
Awesome. I'm in a presentation mode, so I would appreciate if you kind of, capture the questions or save them until the end when I will, switch to a conversational mode, and, we can definitely cover whatever questions you have there. Meanwhile, feel free to, if something comes to mind, put it in the chat window, and we'll definitely capture it and address it. And I will be relying on my trusted partners, Nick and Andy, to interrupt me if interruption is needed. So that said, I just wanted to kind of dive into this presentation that we have titled Unlocking AI Potential, Exploring the Exciting World of Artificial Intelligence. As Nick already mentioned, I am a technologist. I've been in this business of information technology for over 30 years. I feel very comfortable speaking on a wide variety of topics, especially those related to cybersecurity or AI, because I have a pretty strong interest in those subjects. However, I'm not an AI researcher or computer scientist. So if you're looking for some deep knowledge of AI, you probably came to the wrong place. This is going to be introductory, high level, going to go over some history, some potential uses, some potential pitfalls, and what to look forward to. However, just like with ethical uses of AI, something that was asked just a few minutes ago, if you have some follow-up questions on things that you want to explore further related to AI or any other subject, that this community typically discusses, please let us know, give us feedback. As Nick always says, feedback is a gift. We're going to treasure it and going to follow up on it and arrange it for a future presentation. With that said, let's move on. All right, so first, I guess the shameless plug that I want to put in. When I started working on this presentation, and it was a few months ago, it was at the time when ChatGPT was discussed a lot, I revisited some of my notes that I put together a couple of years ago or 3 years ago in 2020. They're available where I published them on LinkedIn, and I looked at that article and I found that it was actually, minus some, new developments, pretty on point and up to date. But then I decided to update it anyway. I updated it by asking ChatGPT to look at that article and give me a summary. A very short, like literally like, a couple of pages, like one paragraph summary. And that's what ChatGPT came up with. I also want to mention that the presentation is going to contain a lot of links, a lot of references. No need to worry. I will make the entire presentation available in a PDF format afterwards. So don't need to, if you see something that is of interest to you, no need to try to capture it necessarily, because I will be supplying all of that later on. So the subject of artificial intelligence, I view it as this, kind of Venn diagram, or, sometimes I refer to this as a Russian doll. So there are kind of domains within domains within domains. There is this general idea of artificial intelligence. Within that artificial intelligence, there is a subdomain of machine learning. And within that, there is deep learning, and so on and so forth. And this is not an exhaustive list. This is just an example. But overall, just to get an idea of what is artificial intelligence, how do we view it, what is the essence of it? Well, it's a program, it's an algorithm. It's something that computers in this particular case execute, just so that we're clear. And machine learning are specific algorithms that implement those machine learning models that we're going to talk about later. And once again, the deep learning is a subset of that. When many layers of machine learning are strewn together, then we get into the deep phase, the deep learning. Then I thought that it would probably be useful to set a frame of reference of some sort and kind of talk about what is intelligence, generally speaking, before we even get to artificial intelligence. And of course, these are like, actively discussed topics. There is no wide-ranging agreement of what intelligence is. We simply do not know yet, but there are lots of different ideas. So I say you might define it as an ability to learn and to perform, suitable techniques to solve problems and to achieve certain goals. And it's all done in the context of the real world, which is always uncertain and ever-changing. So things like, for example, the game of Go, the game of chess, the game of Jeopardy don't really fall into this category because there are very simple, straightforward rules and boundaries, and they're not changing. The rules are set. This game of life in the real world, the rules are always changing. So that intelligence implies that you should be able to solve those problems in the world that's ever-changing. Well, artificial intelligence, you can basically say that we typically ascribe intelligence to animate objects, and maybe artificial intelligence is the same thing as we apply it to inanimate objects. But overall, the coin was kind of termed, this is also open to debate, but I think there is a fairly wide consensus that it was coined by the Stanford professor John McCarthy sometimes around 1955. And it was simply defined as the science and engineering of making intelligent machines. What does intelligent mean? See above. And one anecdotal quote, I guess, is that in 1956, soon after this was kind of coined, this term, there was a summer research project at Dartmouth. Lots of smart people got together, and they basically launched the AI field, and they proclaimed that they can get great progress done by basically just putting a couple of months of work into it. A summer, an artificial intelligence problem will be solved. Well, it's been many, many years since 1956. It's still an ongoing research, and this has not been solved as a problem. So we set a lofty goal. We've yet to reach it. Also, if you want to kind of explore maybe other definitions of intelligence, I threw a few together that kind of resonated with me. I cannot say that I like all of them equally. I cannot say that I like all of them in their entirety. I like bits and pieces, but you can browse on your own and kind of figure out and find the description of the intelligence or artificial intelligence that resonates the most with your understanding of it. I perhaps would probably go for the Oxford's definition, but that would probably be the one that is close to the way that I would define it. Also, artificial intelligence, comes in, many different types. Here we're talking about at a very, very high level. So we can probably define artificial intelligence as, those three broad categories. First, there is this artificial narrow intelligence, and that's pretty much where we are right now, by my personal estimation. It also often referred to as a weak AI or narrow AI. It is goal-oriented and designed to perform tasks in a singular domain, like, for example, self-driving cars or speech recognition. Or you may have your, Rumba vacuum cleaner. It's a robotic device that runs some artificial intelligence algorithms. It can only do one thing. It can sweep the floor, pretty much. That's it. So that's why it's narrow, and that's why this artificial intelligence is defined as weak, and that's pretty much where we are, and we'll continue to iterate and continue to enhance this narrow intelligence as we go forward. Where we're aiming, and hopefully in the near future, is artificial general intelligence, also often referred to as a strong AI or deep AI. And that concerns the concepts of machines, being able to perform, tasks across different domains. So basically, any problem you throw at it, it should be able to solve, regardless of, what domain it is from. So that's kind of, very promising. There is a kind of active debate as to, are we there yet with ChatGPT? Are we not? I think the quick answer is not quite, but maybe soon we'll be heading in that direction. And then there is a slightly distant future, at which point we may reach artificial superintelligence. So this is, where we may find ourselves, and that's where all the, fears concentrated. That hypothetically there will be this AI that is not only good in all of the different domains of knowledge, regardless of what it is, but also it's superior to human intelligence in just about each and every way. What's the worry about that? Well, we may not be able to control it. It may decide that we as human beings are obsolete. And there are many other kind of, reasons to be, kind of aware of where this is all heading and to be careful about it. Clearly, as we design those AI algorithms, as we implement artificial intelligence, we got to make sure that, things related to ethics and things related to security and things related to safety are at the forefront of this research. And whatever we do, should be implemented in a secure fashion. But most of the hype surrounding AI is like, hey, we're heading to this, AGI moment when, we will have machines that are able to do things across all the different domains of knowledge. And then there is this fear about, reaching the point, which is also sometimes referred to as singularity. When we get to artificial superintelligence, when computers and other forms of artificial intelligence are so superior to humans, and once again they may decide that they no longer need us for whatever reason. So that's kind of where we are, where we're potentially heading in the near future and slightly farther outlook. AI also has different approaches. It's not kind of a uniform field. Right now, most of the focus is on the area of AI that is called machine learning. It's one way of doing AI. And it was defined around 1950s by another AI pioneer, Arthur Samuel. And he defined it as a field of study that gives computers ability to learn without explicitly being programmed. So we just give them a framework. We don't give them the rules. We don't tell them what to do. We set kind of broad guidelines, and we train them on a lot of data. And then they basically are able to figure out certain things on their own. This is definitely not the only approach to artificial intelligence. And this is not an exhaustive slide, but to show you a counter to what machine learning is that we're going to be discussing in more detail. Let's say there is another approach to AI called symbolic reasoning. Expert systems that were pretty popular not too long ago represent actually this symbolic reasoning framework for doing artificial intelligence. And that's a framework where computers are programmed with a lot of rules, with a lot of data, databases, what if, then kind of things. And that rules engine combined with, the huge knowledge base is what driving that type of artificial intelligence. It's definitely not machine learning. Machines don't learn their own. When you're doing symbolic reasoning, it's more of giving them the rules and giving them the knowledge bases. I mentioned I'm not an artificial intelligence researcher, but I dabbled with it a while ago. So like in early 90s, in 1990, I think I purchased and read this book that basically says programming in a language called Prolog for artificial intelligence. And this concentrated heavily on the symbolic reasoning and the expert systems aspect of it. Also, if we bring it into a more modern age, possibly many of you who have been in college recently, school, or have kids in school are familiar with Mathematica. It's a program, or for example, Wolfram Alpha. That's another kind of example of symbolic reasoning type of artificial intelligence application. But following this machine learning paradigm, there are different approaches to machine learning, just like there are different approaches to artificial intelligence in general. So one of the approaches to machine learning is deep learning. It's just part of kind of broader family of machine learning methods based on artificial neural networks. And the neural networks, they call neural networks exactly for the reason that they try to mimic how human neural network works. So we use neural networks to represent learning, and that learning can be divided very broadly, probably into three high-level basic categories, even though I mentioned here four, but I'll explain. So those categories are supervised learning, unsupervised learning, and reinforcement learning. Just to kind of very, quickly, supervised, learning is very simple. You need to give computer, some data that's already been kind of pre-reviewed and pre-labeled. To use a very simplistic example, let's say we're trying to create a neural network, deep learning network that's going to look at the pictures of animals and sort them into two piles of cats and dogs. Well, if you're doing a supervised learning, then you will actually have a bunch of photographs already pre-labeled, cats with, cat label and dogs with dog label, and you will train your system on it. So that's the way to supervise the learning process. Unsupervised is completely opposite to that. You basically have a lot of data, a lot of pictures, but you let computers figure it out on their own. Nothing is pre-labeled. And the reinforcement learning is a slightly kind of different paradigm. This is where you constantly, providing a reinforcement, basically telling computers, providing feedback to those neural networks, telling them whether or not the decision that they made about how to categorize stuff is strong, good, or weak, bad. The slightly weird case of semi-supervised, learning method mentioned here is a combination of supervised and unsupervised learning. So first, a very small set of data that is labeled, that followed up by the set of data that is unlabeled, and computers learn kind of in stages. The first round of learning is done in a supervised fashion, then unsupervised fashion. So hence the moniker, semi-supervised. But all of those things, fall into the category of deep learning. Much like the approaches to AI itself, machine learning and deep learning is not the only paradigm. Within machine learning, we can also have like statistical pattern recognition, tree induction, and many other types of learning. So deep learning or neural networks is just one example of it, the one that seems to be the most popular. So we're following this branch of the reasoning. But if you want to learn more, once again, I'm including some references here. You can visit them and see there is a long list of different approaches to doing machine learning. Also, as you will see representation here, it kind of looks like a human brain with potentially neurons and connections, synapses between them. Of course, this is just a representation that's done as a picture for us to understand it more easily. But in fact, when implemented, within the computer systems, all of those nodes, all of those, artificial neurons, they're mathematical formulas. And connection between them are different weights. So depending on whether or not, you go from neuron to neuron and you get a, more positive, more precise result, then the connection between those two will be reinforced. So the future pathways are kind of favor this particular connection versus something else. And we call it deep learning. So any neural network that has like a couple of layers would be considered a neural net. So there is always an input layer, there is always an output layer, and then there are hidden layers. So one or two hidden layers doesn't constitute, I guess, the notion of deep. It would simply be, a neural network with machine learning. But when you have many hidden, layers of those neural nets, then you refer to it as a deep learning. Also, there are different approaches to the deep learning in neural networks. One that became very trendy and very popular in a not too distant past is the one called transformers. It's a kind of a novel, a new approach to neural network architecture, and it aims to solve a problem of kind of handling human type of interactions, being able to sustain the conversation just like ChatGPT does, and we're getting to ChatGPT, don't worry about it. So this is, how basically, kind of the sequence tasks, are being enabled by this particular type of, neural network. It was first kind of designed for natural language processing, which is a field in and by itself. Transformers were extremely successful, and it all started with one research paper that I reference here called "Attention is All You Need." So it's not only being able to sustain those kind of long-ranging conversations, but it's also being able to pay attention to context of what is being asked, and paying proper attention to those things is what enabled and what made this transformer type of neural network very effective, very efficient, and thus very popular. And it started with natural language processing, but then extended into all sorts of things. But of course, transformers are not the only approach to deep learning and neural networks. And I cite a few other approaches here, and then the links below provide even more information to that effect. Moving down the tree branch, we come to the large language models, or LLMs. You probably heard that. So what is the large language model? Well, first of all, it's a neural network. Second of all, it's based on the transformer architecture. Third of all, why is it large? Well, number one, because it has a large number of parameters. And parameters are different variables that are being adjusted as the system learns. First, the system or a model enters a state with randomly assigned parameters, randomly assigned variables. And then as you continue to learn the network on a huge corpus of data, those parameters those variables get tuned. So the number of those parameters is huge nowadays, and that's why we refer to it as a large language model. Also, the quantity of data on which that model is being trained is huge as well. So that's why we refer to those models as large language models. They emerged around 2018, and they can perform a wide variety of tasks, even though initially they were designed specifically for language processing. So, just a quick note that in neural networks, parameter I already said refer to variables that are learned during the training process. It may include those weights that make certain passes across the neural network more preferred than other paths. And those weights and the variables that they're all being assigned some kind of numerical values that are constantly being adjusted when the model is trained. And then when it's set, basically that's the value that you're going to have going forward. After the model has been trained, you're just going to continue to use it. The retraining is possible. That may introduce new data and make model even better. But overall, the training of those neural networks is very expensive exercise in terms of the effort and resources. So once you train it, you want to get full usage out of it. You don't necessarily want to retrain it, or definitely don't want to retrain it too often. So we're kind of putting all of those things together and coming to the ChatGPT question. But basically, I mean, we have started it with a general kind of notion of AI, then moving from AI to approach to AI, which is machine learning, then neural networks that are part of the machine learning, and then LLMs that are basically part of this neural net concept based on this transformer architecture. Of course, this is a pretty vibrant ecosystem. You'll see in a picture here in the bottom left corner that there are different implementation of large language models. There are many of them. This is not an exhaustive list, but just to give an idea, that ChatGPT that I keep referring to and everybody is hyped about is not kind of the only game in town, so to speak. This slide shows you a quick kind of progression of those large language models. As I mentioned, they were introduced around 2018, and then the development of that, started rather quickly. And as the years passed by, those large language models continue to get larger and larger. So on this timeline, you only see those that have more than 10 billion parameters, those variables, the weights that are being constantly changed while the model is being trained. That's a pretty significant number, 10 billion. And you'll see how progression goes. You also see the vibrancy of this particular ecosystem. You'll see that there are lots of commercial models. There are lots of open models. Those highlighted in yellow are open source models that you can simply download and play with on your own for free. Hugging Faces is a good source for navigating to and discovering those open source models, downloading them, reading about them, and using them. Now I talked about that, that LLMs are trained on a huge corpus of data. So, and the data may vary. It all depends on what data you're training the model on. That's what it's going to be good at. In many cases, the models are being trained on something that is, pretty, genetic in nature. It doesn't really, have any sort of, specific flavor. But then you will, like, for example, what you see, here under T5. So that was, mostly, trained, or not mostly, 100% trained on, the web pages, which contain varied knowledge on varied sets of subjects. So it's not really specific to anything else. Contrary to that, if we look at the alpha code, for example, it was specifically trained on the software code. That's why it's what it's trained for. This is what it does best. And then there are, of course, a combination of those things. You mix and match, and this is how you get models that can actually do lots of different things, from natural language processing and interacting with human beings to either explaining the code to human beings or writing the code for them. So it's all about the training data sets and what exactly is included in that mix. Well, blah, blah, blah. I guess maybe this is all kind of dry, and I'm not sure if you guys, got anything out of that, but, that I'm sort of building up to the subject of ChatGPT. This is what all the recent, at least, hype is all about. So what is ChatGPT? Using all those things we previously talked about. Well, first of all, ChatGPT it's an application, and it was built by a company called OpenAI. ChatGPT can answer questions, can write, documents, can draft emails for you, can hold conversations back and forth, can explain you code. I think I covered many of those things, many of those examples already. And it can write code in different programming languages. It can translate natural languages to code. It can translate between different, languages, and so on and so forth. So it's not specifically for, it's not only for language, but it's definitely language driven. So if we take this ChatGPT and break the name, in parts, then, well, chat means it's intelligent chatbot. You can interact with it, you talk to it. GPT stands for the Generative Pre-trained Transformer. Generative means that it can generate content, new content. It's going to be similar to something it's been trained on. So it's not going to be truly new. It's not going to be very original, but it's going to look like it's an original content. It's going to sound like it's an original content. The ChatGPT is going to generate it for you. Pre-trained, it means that this model that they have chosen has already been trained. You don't really need to train it, you just use it. It's been trained on a huge, corpus of data. The data is unlabeled data, so that means unsupervised learning, what we have talked a little bit about before. And this, type of, pre-training doesn't have any long-term memory, so it only knows of the things that it's been trained on up until that time when, the data was, supplied to it. It doesn't know about all the new stuff. As new things become available, new knowledge becomes available, well, the model is not going to be aware of that unless it is retrained on the data that includes this new knowledge. And transformer, we talked about what a transformer is. It's a novel type of neural network. So putting all those things together. generative, it generates stuff pre-trained. It was already trained using this, unsupervised learning and transformer, a type of neural network that is employed by ChatGPT. Underneath ChatGPT, there is this large language model. It is based on transformer architecture. It has been pre-trained in the generative functions, and it is using unsupervised learning. And after it was unsupervised learned, it was trained in unsupervised fashion. It was fine-tuned a little bit. And the secret sauce that it seems to be, it's not fully disclosed, but it seems to be this reinforcement learning with human feedback, or RLHF, what typically refers to in AI circles, is this additional layer that after the model was trained, after the model was tuned, there is also additional training step when the model provides some answers, and there is this the human feedback. The human looks at the answers and deems them either satisfactory or not, and that contributes to the next phase of training of the model. When all of this is put together, you get this amazing thing that we all can interact with, called ChatGPT. So why does it matter? And specifically, why does ChatGPT? Clearly, there are other things, and this is a very fast, developing field, but ChatGPT captured, at least initially, all the attention. Well, there are a number of reasons, why. I've outlined three that, resonate with me the most. Well, first of all, it's the explosive growth and adoption of ChatGPT. It's estimated that it reached like 100 million, monthly active users, by the January, and it was like, literally introduced like a month before that. So, in 2 months' time, it actually became sort of, more popular and more used than some of the biggest applications out there, like the Facebook and Instagram and so on and so forth. So it was able to reach this momentum in a fraction of the time that social networks, for example, that I've just mentioned, were able to do that. And social networks are designed for people to interact with them. ChatGPT is sort of, an obscure thing. Until ChatGPT came about, who wanted to talk to an AI? Well, not too many people other than AI researchers. So given all those constraints, humongous popularity within a very short period of time. There got to be something there. It's also one of the top 50 most visited sites in the world. And there are sites like Wikipedia that people visit on a regular basis because it's a source of tremendous amount of knowledge. This is just an interaction with a chatbot. So it's like, once again, there got to be something there if people like it so much. And by the way, this 50 most visited, maybe slightly outdated. I put this presentation together a couple of months ago. Now it may be in top 10. Who knows? And of course, it's all about people. Behind this OpenAI and ChatGPT brand, it's a brain trust. It's a bunch of people who either entrepreneurs who actually have a proven track record, like Sam Altman, for example. I believe he was one of the founders of Stripe and some other companies. And also the brain trust of like people such as Ilya Sutskever, Mira Murati, Greg Brockman. You see a list here. It's once again not a exhaustive list, but these are some of the best known AI researchers that have some of the most cited AI research papers in the world. So that's why we also need to pay attention to this. There are very smart people working on this. Obviously, there are other outfits all around the world. Microsoft has a strong AI research team. Google has a strong AI research team. DeepMind, of course, Meta is very strong in AI. But overall, the number of people who are very deep into AI research is not that big globally, and a good chunk of them is working for this company called OpenAI that created this product called ChatGPT, with which we mere mortals can interact. And I really like the quote I read somewhere that like ChatGPT is to AI what Netscape was to the internet. Hopefully you guys remember the Netscape browser, one of the first really useful browsers out there. So internet existed before Netscape, but once Netscape came along, the average user, like you and I, could actually interact with internet in a very easy way, and we could see the potential. We could see what we can do. We can see where it all leads. Similarly, this field of artificial intelligence and research and natural language processing existed for many decades, but it was mainly kind of confounded to research institutions and people who specialize in computer science and AI research. All of a sudden, ChatGPT comes along, makes the fruits of that labor available to anybody via simple, conversational AI, conversational UI, user interface. So that's what kind of, drives it. Number two, of course, is capitalization. There is a lot of money in the companies who actually do AI, and OpenAI with ChatGPT is one of the best capitalized. When you look at the number, you'd be quite amazed. 29 billion. Once again, that's a few months old. So very smart people, strong finances, strong capitalization. And number three is probably the most exciting. It's just looking at the results, looking at the capabilities that ChatGPT has demonstrated. And this too may be slightly outdated, but these are all the different tests that ChatGPT either aced quite easily or done very, very well on, pretty much comparable to human level of performance. So those are the reasons why we need to pay very close attention to this emerging field of artificial intelligence as it becomes more practical and more usable, and more specifically to ChatGPT, OpenAI, and related things. Other pros and cons, of course, just like with anything else, there are huge opportunities, there are many limitations, there are some serious concerns. I'd probably start with limitations. So first, I mentioned that the model is kind of trained, and after that, it doesn't really have sort of capabilities to acquire additional knowledge without being retrained. So well, there is limited knowledge, and that limited knowledge specifically applies or multiplies when it comes to like new niche topics for which there may not be huge amount of data to train a model on. Incorporating new knowledge also is problematic, as I have mentioned, because the model needs to be retrained. The answers that AIs give us nowadays, not always correct. Sometimes it is known to hallucinate. This is a technical term, actually, in the AI research we call hallucination, when it just makes the answer up, but it gives it to you in such a fashion that you're almost convinced that this must be factual, but it's not. So it needs to be checked. Also, even though they're getting better, all the different AIs, including ChatGPT, they're still not particularly good at solving things like complex mathematical questions with accuracy. Sometimes they're okay with ballpark, but it's really not a precise answer that they give you. They're getting better with additional kind of algorithm, additional training, and also things like plugins. If we specifically talk about ChatGPT implemented a number of plugins. One of those plugins is to Wolfram Alpha that I have already mentioned, that actually does mathematical computations very, very well. It's rooted in the product called Mathematica, also from Wolfram Research. So it's specifically designed for that purpose. So by using plugin, when you ask a question that is, on the subject of, complex, mathematical equation of some sort, the ChatGPT will understand the question, using the natural language processing, will understand that it's a complex mathematical issue. It will start the plugin and basically farm this to Wolfram Alpha, get a precise answer back, and then use its natural language processing capability to give you a very well-formed, humanly readable, understandable answer that includes this precise calculation. So that's the way to kind of augment and extend, and to plug in some of the weaknesses of just the basic, ChatGPT type of AI. It also can summarize things really, really well, but those summaries typically don't include unique insights, because this is not something that it is particularly strong on, those like kind of unique insights, the unique new things, because it will give you something that is similar to something it's been trained on, but not necessarily something that is totally novel and unique. There is also a limitation in training data, because well, data, just like humans, actually has bias. Most of the data that the AIs are trained on are generated by humans or collected by humans. The data includes human biases and other biases as well. Of course, companies like OpenAI and others who operate ChatGPT and other similar AI platforms take great care of taking the data, cleaning the data, debiasing the data via different means. So there are multiple steps before the data gets to the model on which it's being trained, but still it represents an issue. I mean, that problem is not completely solved. There is, of course, limited understanding of emotions and context. Artificial intelligence can only do so much at this point in time. It's really not human intelligence, so it doesn't understand, emotions, and sometimes doesn't understand the context very well. It also is limited in, kind of sophistication and creativity. It may appear very sophisticated, but it really isn't. Once you start interacting with it more, you kind of discover those little things, and you understand that it's giving you the answers that it kind of knows about, but it's really not all that sophisticated, and it's not all that creative. So that goes back to this, like, unique insights or some novel knowledge. I mean, it's not going to do that for you, but it's going to give you an appearance of creativity. It's going to give you an appearance of sophistication. But if you're not after the appearance, but after the real thing, it may not be able to give you that. There are also issues related to stability and capacity. There are, huge kind of storage and compute requirements, and all of that, of course, equates to, like power consumption and other things. So there are huge costs associated with it. And also, when you run those like large clusters, large computer systems, large neural networks, well, stability, manageability of those systems becomes a problem. Generally speaking, capacity becomes a problem. And, ultimately, it all equates to some other resources, like, for example, electrical power and, money. The larger the model, the hungrier it gets, the more it costs, and that kind of creates a loop that is, self-reinforcing and not particularly in a positive, fashion. So those are, some of the limitations, and those limitations feed concerns. There are definitely, legal concerns. Like if we ask AI and we think that it actually creates something new, even though it may not be truly new, but let's say, we think it created an intellectual property of some sort. Well, who does this property belong to? To AI itself, to the company who runs AI, to you who asked the question, to some other, intermediary, to a person who developed the algorithm. So I don't think that has been settled. I mean, there is a lot of, kind of research and thought that is going into that, and we need to have a legal framework that supports our use of AI. Similarly, someone asked me about like ethics of it. Well, yeah, there are lots of ethical questions around this, from bias to violence to plagiarism and so on and so forth. Those issues have not been solved, but they've been actively discovered. They've been actively worked on. Similarly, there are regulatory concerns. It's like, well, what are the regulations? We want to have a framework. We want to have a governance of those things. We have governance, pretty much for everything else we do. We should also have governance for and regulations for AI. There are serious cybersecurity issues, and they're, related to the copyright, to privacy, to misuse, to bias, to truth and accuracy, to transparency, and so on and so forth. None of that has been, once again, there is a lot of work, going in those directions, but, none of those issues have been solved. They've been, actively worked on. Bias I've already mentioned, truth and accuracy I've already mentioned, misuse, of course, AI can be used for good and for evil. It's just a tool, just like anything else. So we got to be careful in, how we enable the AI, what scenarios we enable, what boundaries and guardrails we put around it, who is allowed to use it, how people are allowed to use it, to what goals, to what outcomes. Also, there are serious worries about the total economic cost of this, explicit and implicit, right? So it's like, well, education, inequality, jobs. Is it going to take AI coming along? Is it going to take some jobs away from us? Will there be any shifts in, the types of jobs that, humans are left to do, and what will AI do? How will it figure into an inequality? Because sometimes it requires a certain level maybe of education or affluence in order to gain access to AI systems. So will it amplify the effect and make inequality even worse than it currently is around the world? Similarly, education, how is it used for education? Is it used for good? Is it used for plagiarism? Is it enhancing the outcomes, or is it causing the opposite effect? Serious issues. And one of the bigger ones is probably environmental impact. I already mentioned it's extremely power hungry. There is definitely exhaust. There are definitely, greenhouse gases, related with it. There is a huge environmental footprint. And as AI and the models that support it and neural networks and computers and clusters that run it gets bigger, and bigger, so are the environmental impacts. So we need to be cognizant of that. And we need to make sure that we have plans in place on how to mediate it, maybe using more renewable energy to support this type of activities and stuff like that. But with all of the limitations and all of the concerns, I think opportunities are just tremendous, and they, in my personal, of course, opinion, way overweigh the concerns that we have and limitations that we have. Limitations we're currently working on enhancing or removing some of those concerns. We're actively working, and we're going to continue to work on addressing them. But opportunities are abound. I've mentioned a few use cases already, but just to outline the few here, hey, compiling and summarizing research. There may be a huge research paper, hundreds of pages long. You may not want to, read it entirely. You may want just a quick summary, and you want to know important things. You can ask an AI program such as ChatGPT to summarize it for you, and it usually does a very good job of doing this compiling and summarizing thing. So then you only need to read a couple of paragraphs or maybe a couple of pages, and it gives you a gist. And then it's like, if it's applicable, if it's something that is related to your area of interest or your research, then you may decide whether or not to read the entire paper. Also, creating, content or synthesizing, editing, and reformatting text, some very kind of, novel and unique things it may not do well, but it can synthesize a lot of stuff based on the knowledge that it already has. And you may feed it some articles and say, hey, synthesize me, or, reformat it, or write me something similar to what I just fed you. Reformatting is yet another thing. You can give it a lot of text and say, hey, please, can you reformat it in a form of essay, and please, have the intro, the main part, the conclusion, and it can do an awesome job and very, very quickly giving you the result that you desire. And you can continue to interact with it and continue to refine that, output until you're satisfied with it. Brainstorming, evaluating ideas. This is what I kind of, use ChatGPT and, similar type of programs quite a bit for right now. Sometimes I, need to have a conversation. Sometimes I need to have a presentation. Sometimes I need to write a white paper of some sort. And I usually, not often, but well, not usually, sometimes have a hard time starting. Where do I start? I seem to know a lot about this subject, but I don't know where to begin. Well, just by having a conversation with ChatGPT and asking it some questions and having them give me answers back, I actually, clarify things for myself. And, after a short conversation, it's like, okay, I think I got a plan in my head, how to start and where to go with it. And once you have a kind of a working draft, you can feed it back to ChatGPT and get some feedback, from this program and refine it some more. And then you're on your, way to creating the final product. It can also do writing, debugging, and translating computer code. I've already mentioned that. I actually use ChatGPT for that quite a bit as well, often asking it, feeding it some snippets of code and asking it, can you explain to me what it does? It may be from the language that I'm not particularly familiar with, or it may be at the level that, I'm not particularly at. I'm not an, active programmer. I, do programming on the side. I do a lot of scripting. I do a little bit of programming to support some, other investigations that I do, but that's not what I do day to day. So it may kind of exceed my level of competence. And if I cannot quickly figure out what this, particular part of code does, I can continue researching on my own and eventually probably arrive to the answer, or I can very quickly ask ChatGPT and it will provide me with a pretty good explanation that additional research is no longer required. So time saver for sure. It can definitely assist, teachers in administrative tasks. Sometimes you need to create quizzes, you need to create lesson plans or other documents. You give it some information, you give it a subject on what to do it on, and it can very quickly summarize stuff for you, give you those like lesson plans, give you those quizzes. Similarly, it can be used as a tutoring aid or tutoring guide for students to help them progress with the courses. Once again, if you use it yourself or if you have kids, school age, Khan Academy is a great resource. I had a couple of kids in school not too long ago. I know I used, Khan Academy a lot myself. Often to refresh kind of, my understanding of things, or to make sure that I explain things, correctly at the level that is appropriate to the grade level of my kids. Well, now Khan Academy actually includes an AI tutor that can help students to provide additional kind of guide and training resources in order to understand the subject matter better. And it can also help students practice for tests and stuff like that. It can also help with automating different processes like a sales process. The intelligent ChatGPT infused chatbot can interact with users, understand what their desires are, what they're looking for, and answer back and give an appearance like you're dealing with a human agent. So it can definitely, help with those processes. Delivering, customer service and customer care. I mean, that's a, pretty obvious example. Streamlining and enhancing, processes using, different automation techniques, including writing some of that automation code that I have mentioned. Sometimes you don't know how to glue things together. It can help you do that. Translating text from one language to another, because it's really kind of language agnostic. It can actually be used for translation purposes. And things like smoothing out onboarding process. You may have a chat-based AI that actually interacts with your new customers or new employees, guiding them through the process of onboarding the new customer or onboarding a new employee. This is just a small portion of what is possible. But even those opportunities, I think, give you a view into potential use cases, and it's going to become like exponentially more and more and more. That's why, in my opinion, opportunities overweigh limitations and concerns by a large margin. And I include a quote here from McKinsey, a preeminent consulting firm that basically estimates that AI will continue to grow and deliver additional economic, output of around, US 13 trillion by 2020. This is going to increase the global world GDP by almost 1.5% on an annual basis. So this is actually quite interesting, and it's going to be very, very impactful. So you do need to pay attention to this. Just learn more about it, use it. Well, with all of that, it's like, well, when it comes to, domain of cognition, will we be, replaced, or what's our, rightful place? Once we start using more and more those neural networks, the AI programs, and as they get smarter and better and more capable and move closer to be in a, area of like general AI, good across multiple domains. Well, we need to find our niche, and we need to make it so that just like with any other revolution, like with industrial revolution, it removed a lot of manual labor. It put it on the machine. Then human can do other things that are more mental than physical, for example. Similarly here, we need to find things that are sort of centered on what we are good at, the human beings, which is usually creativity and like creative problem solving. Those types of things. And I wanted to sort of kind of compare, our human brain with, let's say, OpenAI's, ChatGPT. Since we're talking about intelligence and artificial intelligence, since we're talking about neural networks and they're modeled on human brain to an extent. So how do we compare? And this is just kind of approximation that very smart people put together using very interesting approximation techniques. There is no sort of specific number. There is no wide agreement on how many billions of neurons human brain has, but there is an estimate that about 100 billion. And those different neurons in our brain have connections between them, synapses. And we estimate about 100 trillion connections for the 100 billion neuron brain that we have. And that is estimated to equal about, 1 exaflop. And that is, the floating point operation. This is something that is similar to how we rate our computers. With all of that, so, we, the humans, an individual human can do an estimated exaflop. The supercomputer can do about 1.1 exaflop. So they're slightly better, but they're considerably bigger. When we talk about supercomputer, we're talking about computers it's not a singular computer on your desk. It's a computer it's a number of computers that occupy a room and require a lot of network connectivity between the different computing nodes, that requires a lot of power, a lot of cooling, and a lot of software to run. So with all of that huge supercomputer is only slightly better in terms of performing, operations than the human brain is. Of course, we don't do it the same way. We can't really compare it one-to-one. It's not apples to apples, oranges to oranges, but I think it gives an idea, an order of magnitude, so to speak. Also, with this extreme compute power that we have in our brain, we're only using about 10 to 20 watts of, power to do that. Well, those supercomputers, they use about 21 megawatts. So, they're basically just as good as us, but at a much higher cost and much higher energy consumption. But even though we only use 10 to 20 watts to do those things, I got to say that our brain is a very power-hungry organ when it comes to a human body. The human brain is estimated to only take about 2% of our body weight. yet it consumes about 20% of all of our kind of caloric intake. So it uses 20% of all the caloric power that we get, even though it's only 2% of our body mass. So I just thought those were kind of interesting numbers and interesting comparisons. And also I included here kind of a quick progression of ChatGPT. Once again, it's a large language model. Why is it large? Many parameters. It started around 2018. And at that time, the ChatGPT model had about 117 million parameters. Moving on to 2023, this is an undisclosed number. OpenAI did not disclose the number of parameters. It was ChatGPT 4 that was released not too long ago, but it's estimated to be about 1 trillion. So 1 trillion parameters, you can probably kind of relate that to those 100 billion neurons, 100 trillion connections of a human brain. Once again, just for comparison purposes. But with all this power, well, clearly computers are evolving and moving forward much faster than human beings. There is this Moore's law, the number of transistors is increasing, the software is getting more efficient, we're getting more memories into those computers, more network connectivity, more data and knowledge is available to them to train on. So their sort of, iteration and improvement cycles are much faster than what human beings can achieve. So we need to be cognizant that computers and computer networks and AI is a very fast-moving field. So where will we find ourselves? What do we need as a human beings concentrate on? Well, if you use this model of cognition, then basically, things that are, related to just, correlating things. Well, AI, that's clearly an AI specialty. AI can do it very well already, and it's going to continue to do it better and better and better. And it's not going to be just domain specific. It's going to move closer to artificial general intelligence. So it will be able to correlate across different domains of knowledge. Causation will probably also be kind of, the area where, artificial intelligence is pretty strong at. It may not completely, replace, humans in terms of that being their specialty, but it probably a good portion of, correlation and causation is going to be a domain where AI does extremely well. And it's kind of tedious, and we probably don't want to do that. Who wants to come through tons and tons of data to find patterns and find, correlations and find some causations? Well, let's just, it's just like manual labor. Let's give it to artificial intelligence and focus on other things that are related to creativity, other things that are related to things that are kind of counterfactuals, meaning that there are no facts for it. Computers and AI is very good, but it's training is based on knowing the facts. It's trained on data. It's trained on facts. If facts don't exist, then there is no way, at least for now, for artificial intelligence to know about it or to derive this or to generate it as part of the generative AI. I think one example that I typically use, it may be slightly in realm of mathematics, so forgive me, but it doesn't really require the knowledge of mathematics. Just a kind of a historical example that long ago, maybe like in early 1500s, in Italy, the polymath and mathematician Girolamo Cardano was working on trying to figure out how to solve quadratic and cubic equations. And he was trying to find an algorithm by which to solve them all, a formula how to do it, not just on one particular example, but on all quadratic and cubic, equations. And he came to the conclusion that he could figure this one out with only kind of one caveat. It would work, whatever he came up with, the algorithm that he came up with would work only if he could operate on a number that was basically a square root of -1. It's sort of a common basic knowledge of high school algebra or mathematics that you cannot extract a square root out of the negative number. So the square root of -1 simply does not exist. But if it did exist, then everything that Girolamo was working on would make sense. So he said, well, I'll call it an imaginary number, and that imaginary number is small I, and it is square root of -1. The general rules say that there cannot be such thing, but I want to extend this framework and say, there could be. I imagined it. It's an imaginary number. So many, hundreds of years later, that imaginary number is actually at the center of, quantum mechanics. Without it, quantum mechanics cannot construct the map of the, real world, cannot explain the real world. But computers would never be able to figure out this, square root of -1 imaginary number because it goes against all the rules that computers know about or have been programmed with. It simply, according to a computer, it simply cannot exist. But we can imagine it. So that's the creative genius of humans, and that's what we're good at, and that's what we probably should be focusing on going forward. And that's going to assure our relevance, our dominance, and our kind of good working relationship with artificial intelligence and computers. This is not quite the conclusion, even though I tried to wrap it up quickly. I added a couple of slides for specific occasions. I'll go over them very, very quickly. But before I added those slides, I basically wanted to conclude here. So draw your own conclusions. But whatever you decide, I suggest that you learn more about artificial intelligence, its uses, the progress, and just follow the progress. Because sooner or later, it's going to impact just about anything we human beings do. So it's better to be knowledgeable, it's better to be prepared, and things like ChatGPT let you actually access it quite easily, experiment with it, work with it, understand it a little better. And then if you have strong interest, you can actually dig deeper into it and do more deeper experiments with AI, including training your own models or figuring out how to program those models, how to extend those models, how to create different plugins for those models, for example, and so on and so forth. But to give you a few quotes, they may be useful or maybe not. One guy said, computers are useless. They can only give you answers. Of course, it was a famous painter, Pablo Picasso. What he meant is that they cannot ask the smart questions. They can only give you answers to the questions we humans give them. And that was, later on, supplemented by another smart guy, Dave Ferrucci. He actually is an AI researcher, formerly with IBM. He's the guy who designed computer that won the Jeopardy. So he said, no, computers do know how to ask the questions. They just don't know which ones are important. So that's up to us to, figure that out. Then yet another, smart guy, Joseph Weizenbaum, who was also kind of a pioneer of artificial intelligence and, and computer science. Another book I would highly recommend, Computer, Power, and Human Reason. It has a couple of kind of mathematical formulas in them, but very, very few. It's actually very readable, plain English, very good book, not a thick one. Will give you a good flavor of, what this is all about. So he said that however intelligent machines may be made to be, there are some acts of thought that ought to be attempted only by humans. I believe, Pierre-Yves, I saw in the comments you actually, put a quote that is kind of similar to that, I think. So, some things are better left, to humans because we have this human judgment, because we have ethics, because we have other things that, we cannot imbue into, artificial intelligence types of systems. And finally, this is a quote from the guy Garry Kasparov. You guys don't know, he's the 13th world chess champion, and the guy I admire quite a bit. He wrote an excellent book, a number of books. This one is not on the subject of artificial intelligence, but I still recommend it highly. It's How Life Imitates Chess. But the book that he wrote that specifically talks about artificial intelligence and interactions between AI and humans is called Deep Thinking. And from there is a quote that don't fear intelligent machines, work with them. And that would be my advice to you, as I have mentioned. Environments as different as chess and medicine are showing us that the right approach is to let people exercise their intuition and creativity, supported and double-checked by a computer assistant as part of the well-designed process. So I think the key components here, there got to be a well-designed process of how we interact with artificial intelligence, and then there should be humans kind of driving the process with intuition and creativity, because we can do some things that artificial intelligence may also be able to do. We do it creatively. They do it by recognizing some patterns in existing data. What they will do it maybe even better than us, but we can still do it faster. We don't know how we do it. We just come up, the answer just pops up in our head. We know what the right answer is, whereas, computer, supercomputer, artificial intelligence may take quite a bit to arrive to the same conclusion. So we got to play to our strengths and at the same time kind of use the computer power to double check, to verify. I think IBM was doing this with kind of X-rays, to identify the cases of cancer or something like that. It's completely pattern-based recognition. So computers can do it really, really well. So they can assist the doctor, but they do not replace the doctor. We still require human touch and human judgment to look at the results and what conclusions computer came up with, and to double check and verify computers in this case. So that would be my favorite advice: not to fear intelligent machines, not to fear AI, work with them, learn about them. And we, the human beings, are going to continue to work on resolving and creating, frameworks for resolving ethical issues, legal issues, regulatory issues, and other issues as well. This is very briefly, I gave a quick talk to cybersecurity community. Of course, AI is going to play a huge role in cybersecurity. It's already playing a huge role. I'm not going to bore you with this, kind of, slightly technical data and acronyms and zero trust this and SASE that, but just kind of be aware that, it really is and becoming and is a pretty strong player, artificial intelligence, in the area of cybersecurity, and that it can be used by cyber criminals and also for people who protect you from them. So it's a double-edged sword, right? I mean, it adds capabilities. It can be good for good. It can be used for good. It can be used for evil. So it's up to us to decide the use cases, to police this to an extent, right? To set the rules and to make sure that people who break the rules suffer the consequences. But it actually offers kind of a lot of additional capabilities. I'm mostly interested in cyber defenders, of course, but unfortunately, it may enable some cyber criminals as well. These are just like, a few things that in cyber realm that AI can be really good at, basically recognizing the patterns, right? If you're using your computer systems in a certain way, it's very easy for AI to figure out what that way is. They create a baseline of some sort, and then every time when you use your systems, or not you, maybe, malicious actor is using your system, and that pattern deviates from your normal one, it's very easy for computer systems to recognize. Everything is at the hyperscale now, so it's very easy to do for computers, very hard to do for humans. There is just too much data, too many signals. And finally, this is just something to give you a taste of the outlook. Well, please, stay ahead of AI disruption. Learn more about it. Continue to learn about it. These are all the different areas, all the different fields that are likely to be, we don't know for sure, but likely to be really disrupted by implementation of AI. It's already underway in many sectors. There are different models and different AI programs that already enhance certain things. Like, for example, Bloomberg already developed a large language model based AI that is specific to financial domain. And they have tons and tons and tons of historical financial data, and that's what they trained that AI on. So it may be able to do other things, I don't know, but what it is designed to do and what it's trained to do is specifically things related to, finances and, performance of, certain assets and stuff of that nature, things of that nature. So this is going to continue, pay very close attention, stay ahead of it. Very lastly, I wanted to kind of give you also a taste that when I started working on it, let's say in the Q1, on this presentation in Q1 of this year, what the news headlines looked like. It was, well, announcing OpenAI. This looks promising. We should be, moving forward. We should be developing, certain, educational assets in order to explain this better to, potential users and stuff like that. So it just a few months ago, Q1 of 2023, it was in very kind of initial stages, early adoption, you can say. Kind of people looking at different, use cases and stuff like that. Moving into Q2, you see a lot of stuff. Well, we're already incorporating this AI capabilities into all sorts of stuff. Well, this is kind of a Microsoft focused community, M365, Azure. So I highlighted a few things here that have to do with specifically Microsoft and their foray into AI. They're taking OpenAI's, capabilities and already incorporating it in Azure. So it's available now. The similar type of capabilities will be available in Microsoft 365 as a set of, Copilot programs. There will also be a Copilot for security to access, cybersecurity related things. So very, very quickly developing, field. And then finally coming to like Q3, basically now, you already see how we're taking next steps. There is more and more and more, and it goes farther and farther and farther. And you'll see here how the systems being developed using AI to do things like, modeling proteins, for, I don't know, new drugs or new drug interactions and stuff like that. And it's like literally all over the place. You'll see McKinsey, whom I quoted, they already created a generative AI tool to unleash insights and elevate their consulting game, their consulting efficiency. So like literally it went from early adoption, kind of, talking about it, to really being adopted and extended, to now being kind of surpassed and quickly moving forward with more and more enhanced and advanced AI capabilities in just a few months in 2023. And I'm sure that it's going to continue apace. This is really kind of just some references that I used early on to compile this presentation. I wanted to include them because I will be distributing the PDF if you want to read it on your own. Of course, all the references that, point to resources on the internet, some of it may already be outdated since a few months have passed, and this is a quickly moving field. But some things that are probably going to sort of remain more or less constant are like, serious books written on this subject. I've included a few. They're not necessarily all that technical, but they talk about the promise of AI, the methods of AI, the potential of AI, the issues related to AI. I probably read 99% of them and more on this list, and I would highly recommend pretty much all of them for your leisurely reading. And then, of course, there are a whole bunch of other resources available now, more being available, added to it, every day. I have, like referenced a few videos here. Some videos are pretty quick, few-minute videos giving you just kind of a taste of, some of those things being implemented. Like I mentioned, Khan Academy, building in some ChatGPT capabilities for its, tutor. I'll also mention how Wolfram Alpha, for example, can extend ChatGPT with additional math capabilities and stuff like that. And then there are like long podcasts that are, or long videos that are like multi hours long that go into some of those issues, pretty deeply. I think with that, I will conclude. Hopefully you guys got something out of this. I'm wrapping up the presentation, and I'm happy to answer any questions if you have any, or just simply wrap it up.
Well, first off, Andrew, I just want to say thank you. This was an excellent primer on all things AI. So I certainly learned a few new things, and I thought I was pretty well educated on this topic. So definitely want to say thank you.
Absolutely. You summarized it very well. It was a primer, so thank you.
And some great stuff going on in the chat that was sort of like accompanying and comparing. I don't know that there were any specific
I missed
questions.
all the chat, but
but going back and reading it is going to be really fun for you, Andrew. If there's anything that we didn't cover or any pressing question that someone has in the chat that didn't get answered, feel free to ask now. But I think it was a lot of commentary that was relatable, and people putting their opinions in, which I think is very valuable too, especially with something that's developing as quickly as this is.
Most definitely, yeah. But yeah, I already see some exciting comments about blockchain and other things. Yeah, I'm